Good morning, students. Welcome to EduAccess, Onrund Making Science Simple.
Morning light fills the classroom as students settle down, ready for a new lesson. Today, we begin Chapter 9, Isaprik, Methods of Separation in Everyday Life.
Welcome, everyone. Today, we begin Part 1, discussing why we separate mixtures in science. It's a fundamental concept. Tell me, have you ever picked out stones from rice at home?
Yeah.
Yes, but
Yes, sir.
Yes, sir. My mother asks me to remove the tiny stones before she cooks.
Excellent, Valli. That's one of the simplest methods of separation we use every day.
So the key is adding the spice right at the beginning.
For the flavor to really bloom. I do the same thing with black pepper in my pulao, sir.
It happens to the best of us. We all do that sometimes. Yes, Malli. We all separate things without realizing we're doing science. But have you ever thought, why do we need to separate mixtures? What are your thoughts on this, Valli?
Maybe to keep only what we need.
Exactly. We remove what is unwanted and keep what is useful. From cleaning grains to filtering tea, everyday tasks involve scientific separation.
As we saw in the video, these separation techniques are essential, whether it's winnowing the grains or sieving the flour for a finer texture.
Science is everywhere around us, hidden in our daily work. Welcome to the class, everyone. I hope you're ready, because today we have a very exciting topic to explore together.
In this chapter, we'll travel with two curious kids, Malli and Valli.
Where are they going, sir?
That's an excellent question. Let's look at the map. They're visiting different parts of India to learn how people separate mixtures in daily life. As you can see, the train network connects Haryana, Gujarat, and down here, Puducherry.
That's amazing, sir.
Welcome back to EduAccess. In this first part, we'll explore the reasons behind separating mixtures.
Good morning, students. Welcome to EduAccess, Upurban Making Science Simple.
Malli and Valli were excited for their summer vacation. Their parents had planned a long trip across India.
So who can tell me what these green fields are used for?
Is it for growing rice, sir?
Twice a year, sometimes 3 times. Their first stop was Haryana, at their Nani's house, surrounded by golden wheat fields.
Wow! Nani's courtyard is full of grain heaps. So many different grains. Why are people sorting them by hand?
Hannah.
We are removing stones and husk from the grains better. That makes them clean for cooking.
This process is called hand picking, separating unwanted materials using our hands. Gently sift through the grains like this. See, Malli, you found one.
I found another one, sir.
Very good, Valli.
Malli? Valli, try doing it with your eyes closed. Can you still find the stones?
That's impossible, Nani. They feel so similar to the grains. I found one, but I think it was
luck.
Handpicking works when the impurities are large and few in number, easy to see and pick.
Here, children, fresh vegetable pulao for you.
I don't like these spicy pepper balls.
Look, Malli, you're doing hand picking again.
Black pepper is healthy for you, dear Dilly. Don't throw it away.
After lunch, their mama took them to the fields to see the wheat harvest.
This is where the wheat is sun-dried to reduce moisture.
And the tractor helps them collect the bundles faster.
That is exactly right, Valli.
There are so many grains attached at the end. How do they remove them?
By beating the stalks on the ground. That's called threshing.
Threshing separates grains from stalks 100. Another method of separation used by farmers.
This is how the farmers separate the grains from the stalks, a traditional method passed down through generations.
But the grains are mixed with husk now.
Will they pick them by hand again?
No, there's a better way to separate them. Watch closely tomorrow.
Next morning, their Nana took them to the fields to watch the next process.
To separate the husk from the grains, we use winnowing. As I gently toss the mixture, the lighter husk is carried away by the wind, leaving the heavier grains here. This technique is called winnowing. The wind does the work. It's a perfect demonstration of how it works.
It's amazing to see it in person. The strong breeze carries the lighter husks away.
So, the wind helps us separate the good grains from the unwanted ones. That is called winnowing growing, using air to separate lighter and heavier substances.
That is called winnowing, using air to separate lighter and heavier substances.
Traditionally, we use a bamboo tray called a soup for this task. By harnessing this natural resource, we essentially let the wind take over the manual labor.
So the wind does the work of our hands. That's smart.
It's quite effective in open spaces.
But it won't work inside a room, right?
Well, that's an interesting point. Exactly. It needs air or wind. That's why farmers do it outside. Machines called threshers now combine threshing and winnowing at once. The key advantage here is the simultaneous separation. The crops go in and the mechanism divides the heavy grain from the light.
So many ways to separate grains. This is really fun to learn, sir.
Science starts in our homes and fields. Every simple action teaches a principle.
So, Malli and Valli, after visiting Nani's house, what did you observe?
We saw people removing stones, husk, and even dust from grains, sir.
That's excellent observation, Valli. And all of that had different things mixed together.
Exactly.
Exactly. That's what we call a mixture. A mixture is formed when two or more substances are combined without any chemical change. As you can see here, when we mix the rice and the lentils, no new substance is formed. This is simply called a mixture.
So, sir, rice and stones.
Mixed together are also a mixture? Yes, Valli. Even air and salt water are mixtures, not just food.
So, the air we breathe is a mixture, mostly nitrogen, represented by the blue spheres.
And the red ones are carbon.
Air is a mixture of gases. Nothing new is created, just mixed together.
Let's take another example. Salad made of cucumber, tomato, and onion.
A mixture is when components keep their identity.
That's my favorite kind of science. Right? Tasty mixtures.
Yes, science can be delicious too. Now watch. If I mix salt in water, what do I get?
Daddy.
What do we call the resulting mixture?
Salt solution, sir.
Nah. Right. Salt dissolves, but it's still present. We call it a homogeneous mixture.
Today we are looking at homogeneous mixtures. When we add salt to water, watch how it dissolves completely.
Right. Salt dissolves, but it's still present. We call it a homogeneous mixture. If I mix sand with water, it doesn't dissolve. That's a heterogeneous mixture.
Ah, I see. It's not the same throughout.
And here we have it. The sand clearly separates from the water over time. This is precisely why we label it a heterogeneous mixture.
So, sir, mixtures can look different depending on how substances combine?
Exactly. And that's why we need different methods to separate them.
Mixtures are found everywhere. In food, clothes, air, and even in water.
As you can see from these examples, mixtures are all around us. From the tea we drink, the cement we build with. Remember, in a mixture, substances do not change. They just stay together physically.
So, mixture hante two or more substances combined physically.
Got it. Well said, Valli. Now tell me, what kind of mixture is your breakfast cereal? We can observe that the cornflakes and milk are combined but retain their individual properties.
It has milk and cornflakes. They're mixed but not changed, that mixture too.
Yay! Life hack. Perfect.
Yeah.
You've understood the concept completely.
A mixture is when two or more substances are combined physically dominating. No new substance is formed.
So, Malli and Valli, you saw so many materials mixed at Nani's house. What did you learn?
Hey, what did you do?
The process of separation is crucial in many fields.
Everything was mixed together, like grains and stones, husk and wheat. Yes, sir. Nothing new was formed. When they were just together.
Huh?
Excellent, Malli. That's exactly what we call a mixture.
A mixture is formed when two or more substances are combined physically without any chemical change. As you can see, when we combine the grains, it
Forms a mixture, which is a physical quantity.
does this mean?
We can separate them again.
Anaya?
Sir, is rice with small stones also a mixture?
Ma?
Yes, Valli.
That's a simple example of a mixture found in our kitchen. Now look here. Now come in. Even the air we breathe is a mixture. As you can see, air is fundamentally a mixture of these gases: oxygen, nitrogen, and carbon dioxide.
Are the colors important, sir?
Mixtures can be solid, liquid, or gas, or gray. We find them everywhere in our surroundings.
We've looked at milk, juice, sand, and air as examples of different mixtures. Now, who can summarize what defines a mixture for us?
I can, sir.
Here's another one, Isavis. A salad made of cucumber, tomato, and onion.
A salad is a perfect example of this principle. As you can observe, the components keep their properties.
So my fruit salad is also a mixture.
Yes, that's right, Malli. Yes, Malli. Science is even on your dining table. Now watch. I'll mix salt into this glass of water. What happens?
It dissolves completely, sir.
Yes, that's correct. It is now a homogeneous mixture. Right, that's a homogeneous mixture, Sanav, and everything looks uniform.
As you can see, the salt particles are spreading evenly throughout the water. This is what we call a homogeneous mixture.
But if I add sand instead of salt, what do you observe?
The sand settles down. It doesn't mix.
As you can see, the sand and water remain separate
This is a perfect example.
of a heterogeneous mixture. But why doesn't the sand dissolve?
Mixtures can be visible, like sand and water, or invisible, like sugar and water.
As you can see, when we mix sand and water, the particles remain separate, making it a visible mixture. But with sugar, it dissolves completely. So remember, in a mixture, substances don't change. They only combine physically. Got it, ma'am? Oh?
A mixture oven, no new substance formed.
Excellent, Valli. Now you truly understand what a mixture is. A mixture is two or more substances combined physically, with no new substance formed. Now that we know what mixtures are, let's think, why do we separate them?
To remove unwanted things, sir. Who can pick them?
Yes, exactly.
Exactly, Valli.
Yeah.
That's one main reason, Polly, to remove impurities.
Wait.
Sift it slowly with your fingers, isolating the stones. It takes some practice, but you'll get the hang of it. We separate impurities to make food clean and safe for eating.
Another reason is to get useful components by the store, like milk and cream.
Notice how the continuous churning separates the fat. This process allows us to get these useful substances from the milk.
So, we separate things not only to throw away, but also to collect what we want.
Yes, Malli. Sometimes both parts of the mixture are useful. Farmers separate grains and husk. Both are valuable in different ways.
The strong wind blows the lighter chaff away, separating it from the grain.
So that's how it works. It's very clever. So, we separate mixtures for two main reasons. 1. To remove unwanted material. 2. To obtain useful substances. So today we are learning about separating mixtures.
Sir, when we wash rice before cooking, are we separating impurities too?
That's an excellent question.
Sir, when we wash rice before cooking, are we separating impurities too?
Absolutely, Valli. The dust and husk float away with water. That's also a separation. As you can see, the fine dust particles and excess starch rise to the surface when we gently wash the rice. This is why the water appears cloudy.
Like when we make tea, the strainer separates tea leaves.
Oh.
Yes, Malli. That's called filtration, Milshak, another method of separation.
Now watch closely as the tea passes through the strainer. This ensures a perfectly clear cup every time.
Separation helps us in cooking, cleaning, farming, and even recycling waste. So whether it's threshing grain, washing fruit, or sorting materials for recycling, these processes are essential for sustainability. Let's see more examples from daily life. As the muddy water passes through the cloth, the impurities are filtered out. See how clear it is now?
That's amazing, sir.
We use distillation for liquids.
And evaporation for solids dissolved in liquids.
What about separating salt from seawater? That's evaporation, Wayne. Water changes to vapor and salt remains behind. So, as the sun heats the shallow pans of seawater, the liquid turns into vapor, leaving the salt crystals behind.
Even natural processes like rain and salt formation involve separation.
Now, who can tell me, Dolan Bey, why do farmers separate grains from husk?
Because husk can't be eaten, but grains are useful for food.
That's exactly right. Very well explained. Exactly. And husk can still be used as cattle feed.
As you can see, the farmer is feeding the animals the husk before storing the clean grains in these sacks for later use. In industries, separation is used to get pure materials like iron from sand. Now watch closely as the magnet attracts the iron filings, leaving the sand behind. This process is called magnetic separation. Even factories use powerful magnets to sort metallic waste.
So, can you name some examples of separation you do at home?
These are common methods of separation. Yeah.
Filtering milk, washing vegetables, removing tea leaves, and picking out plastic covers before recycling. And picking out plastic covers before recycling.
Wonderful answers. You all use science every single day. Now, today, we are going to explore how science impacts our daily lives, whether in the kitchen, the field, or the factory.
Separating mixtures makes our lives healthier, cleaner, and more efficient.
So, the purpose of separation is simple: to make things pure and useful.
The purpose of separation leads to purity, safety, usefulness, and recycling.
Now I'll never complain about washing rice again, sir.
That's the spirit, Valli. Everyday chores are full of science.
Now let's try a fun science activity. Malli and Valli. Winnowing. Ready to explore?
Yes, sir.
Yes, sir. Okay, what are we going to do?
What are we going to do?
Take a handful of roasted peanuts. Let us see what happens when we rub them.
As you can see close up, the brown skin of the peanut is thin and papery. These are packed with nutrients.
Sir, should we rub the peanuts softly or firmly?
Rub them gentle between your palms. DY. Observe carefully. See how the dry skins start to crinkle and break away with just a little friction. This is how we loosen them.
The skin is coming off. The peanuts look cleaner now.
What do you notice around your hands?
Tiny peanut skins everywhere, SIR.
Good. Now, can you separate these skins from the peanuts easily? Not really. They're too light and mixed together. Exactly. Let's try blowing peanut gently. What do you observe?
So, the soft air blows the lighter skins away, leaving the heavier nuts behind. This technique is known as winnowing.
Wow.
Wow.
The skins flew away and the peanuts stayed behind.
That's because the peanut skin is lighter Dakar. Air helps separate them. Blowing air separates heavier and lighter components of a mixture.
As the arrows show, the heavier items settle here, while the lighter chaff is blown away. This is how the winnowing principle works.
So, which part was carried away by the air? The lighter one, sir, the peanut skins.
That is absolutely correct. Very good. Very good.
Correct. And the heavier peanuts stayed on the plate.
As the need to cut well again to point them.
So this is how farmers separate grains from husk?
Using wind?
Exactly, Valli. Exactly, Valli. That process is called winnowing. As you can see here, the farmer uses the wind to separate the grains from the lighter husks. This technique is called winnowing.
In winnowing, the wind helps to separate lighter and heavier parts of a mixture.
So, our peanut activity shows how winnowing works tongwin, even on a small scale. This process is called winnowing, where the wind separates the chaff.
But sir, what if there is no wind? The machine uses forced air, right?
Science is everywhere, Sirka. Even in my snacks.
That's right, Malli. Everyday things teach us science if we just observe.
Lighter components are blown away by air. Heavier components remain.
Malli and Valli, we've learned why we separate mixtures funkier. Now, let's explore how we do it.
Are we going to see real methods, sir?
Yes, we are.
Let's explore them together.
Yes. Let's take a quick tour of India to see how people use different techniques of separation.
Join Malli and Valli as they continue their learning journey across India. Join Malli and Valli as they continue their learning journey across India.
Join Malli and Valli as they continue their learning journey across India. Our journey begins with the simplest method, handpicking. Handpicking is used when impurities are few and easily visible.
Like when I remove black pepper from my pulao?
Exactly. That's also handpicking. Next comes threshing Zaide, used to separate grains from stalks.
So this is threshing, the process of loosening the edible part of the grain from the straw.
Threshing can be done by hand, animals, or machines called threshers.
So you see, there are multiple approaches to this method.
Wow! So many ways for one method.
After threshing, farmers use wind power. This method is called winnowing. This process is called winnowing. The lighter husk is carried away by the wind, leaving the clean grains behind. Winnowing separates lighter husk from heavier grains using air.
I'll learn. Just like our peanut experiment, sir.
Very good, Malli. You connected the idea perfectly. The next technique is sieving, used for different sized solid particles.
This process is called sieving, separating materials by particle size. Sieving is used for separating solids when particle sizes differ, like flour and bran.
So that is how we separate the mixtures. Yes?
Can we sieve sand too?
Yes. Builders use sieves to remove stones from sand at construction sites. Let's move on to a new example. Salt mixed in water, a type of liquid mixture.
This animation shows how the heat causes the water to rise, gradually forming these white salt crystals.
Evaporation removes water, leaving behind the solid dough, salt.
So, to clean this muddy water,
Next, we'll learn sedimentation and filtration used for muddy water.
how does that work?
As you can see, the heavier particles have settled. Now we carefully pour the clear upper layer, which we call decantation. You'll also see churning turning to extract butter from curd minerals and magnetic separation to remove metals.
Let's explore some common separation methods you see every day.
All right, everyone, let's quickly recall what we learned today.
We begot our lesson by understanding why separation of substances is important.
So we use different methods to separate mixtures. We start with hand picking, then threshing, winnowing, and sieving. We learned that mixtures are combinations of two or more substances without any chemical change. When we combine substances without changing their core properties, we get a mixture.
So mixtures are just things mixed. No new material is made.
Perfectly said. Perfectly said, Valli.
We also discovered the reasons for separation, to remove unwanted materials or to get useful ones.
To understand this better, let's look at the goals here. Remove impurities and obtain useful substances. And we saw many examples: filtering tea, washing rice, and making butter from curd. We start with filtration, followed by washing the precipitate. Finally, we use the mechanical churner for separation.
Science helps us in every corner of life, from the kitchen to the field.
Time for a quick quiz. Let's see how much you remember. All right, everyone, it's quiz time. Let's check what we've learned today.
I think I know the answer, sir.
Question 1, jigs liquor.
Fixers, what is a mixture?
Very good. Now, based on what we discussed, which of these options defines a compound? Valli, go ahead.
It's definitely A. Two or more substances combined physically. A, sir. Two or more substances combined physically.
Correct. Well done, Lee. Well done, Malli.
Question 2, Upanan. Why do we wash rice before cooking? Now let's look the options for why we wash rice. A, to cool it. B, to remove dust and impurities. Or C, to make it tasty. What do you think, Malli?
Option B, sir. To remove dust and impurities.
Excellent answer, Valli.
Question 3. Which method helps separate salt from seawater?
Based on what we just learned, which of these methods applies? Take a moment to look at the choices: filtration, sedimentation, or evaporation.
That's correct, Malli.
Can you explain why it is evaporation? Wonderful.
Yeah.
You've all become separation scientists today.
So far, Malli and Valli learned how and why mixtures are separated.
Exactly. You both did very well today.
Yes, it makes sense now. In the next part, we'll explore how these methods are applied step by step.
As the train travels across the map, we can see the different regions it connects. Now, let's look closely at how we explore each method in detail. Here at EduAccess, we are making science simple. Subscribe now for part 2. So, what are the key indicators we discussed?
Is a change in temperature one of them?
Stay tuned for the next part.